This Zoom session is being brought to you by the Fractal Inverse Bullseye Horizon. Okay, for today, one of the big ones, the law of cosines. We'll use it to solve side angle side problems and side problems. Also, they could do side angle problems. That I'll mention in the is a section in the extra credit set. Okay, here we go. We start off with a side angle side problem. We put the triangle in the coordinate plane with this side length b along the x-axis. So this point here is at b by 0. This point here is at 0 by 0. Then we elevate by an angle of gamma. We go at a distance a to this point here at coordinates a cos theta by a sine theta. All that fairly straightforward. And then the distance between these two outer points is c. And so we need to figure out the distance between these 2 points from a cos theta by a sine theta to b by 0. Well, its length is c. So c squared equals the sum of the squares of the differences. A cos gamma minus b all squared plus a sine gamma minus 0 all squared. So here we have an equation which we proceed to simplify. The square of this difference is square minus twice product plus square. A squared cos theta, cos squared theta, minus 2ab cos theta plus b squared. This minus 0 just goes away, and so square that, get a squared sine squared theta. Now, okay, of these two terms, a squared cos squared theta and a squared sine squared theta, gamma, excuse me, have a common factor of a squared times cos squared gamma plus sine squared gamma, that plus a b squared minus 2ab cos gamma. Now, cos squared plus sine squared is always equal to 1. So this simplifies to c squared equals a squared plus b squared minus 2ab cosine gamma. And you can take a square root, and c equals root a squared plus b squared minus 2ab cos gamma. So that gives you c in terms of a, b, and gamma, a side angle side problem. Then you can swap around the labels a, b, c, and a, alpha, beta, gamma, and alpha. Just swap them over one letter higher. And you get two other identities. Second, two other identities. Here, a is root b squared plus c squared minus 2bc cos alpha. B equals root c squared plus a squared minus 2ac cos beta. These three laws are the law of cosines. All right. Like I say, it's useful for side angle side problems. It gives you the far side. And on the other hand, from this equation, a squared equals b squared plus c squared minus 2bc cos alpha, we'll solve for alpha by transposing b squared into c squared, transposing the 2bc, and taking an arc cosine. And you get alpha equals arc cosine of b squared plus c squared minus a squared over 2bc. So this given three sides gives you one of the angles. Now, if you swap around the labels, a, b, c, a, alpha, beta, gamma, alpha, then you get the beta is arc cosine of c squared plus b squared minus plus a squared minus b squared over 2ca, and gamma is arc cosine of a squared plus c squared minus c squared over 2ab. Way I always remember is that if gamma is associated with c, we subtract that square, we add the other two squares, and we divide by twice the other two sides products. The book doesn't give a name for it. In fact, it doesn't even list it, but I think this is worth just writing down as such. And I call it the law of arc cosines. Given three sides, you find three angles. So there we are. Now, let's give an example. We're given a triangle, A, B, C, alpha, beta, gamma. We have three sides. A is 6, B is 5, C is 8. What are alpha, beta, and gamma? Okay, it's a simple matter of substituting into the formula. Alpha equals arc cosine of b squared plus c squared minus a squared over 2bc. B is 5, C is 8, A is 6. So arc cosine of 5 squared plus 8 squared minus 6 squared over 2 times 5 times 8. That's the second. Let's see. Okay, I'm sorry. An arc cosine 5 squared plus 8 squared minus 6 squared over 2 times 5 times 8 is approximately 48.5 degrees. And okay, beta, it's arc cosine c squared plus a squared minus b squared over 2ca. You plug in the numbers, out comes 38.6 degrees. Now I can find gamma by adding these two and subtracting them from 180 degrees. But I prefer to use as fresh ingredients as possible. So our cosine law, our cosine of a squared plus b squared minus c squared over 2ab. After a bit of calculation, it's 92.9 degrees. And those are the angles to within a decimal, fraction of a decimal. Here we have, I think they had this as an airplane problem. The airplane flies 150 miles north, due north, then turns 50 degrees eastward and flies 100 miles to its destination. What distance was that from its original departure, and at what angle from north? Okay, first, we have at 150, we have a 50 here. This is there for 130. We have 100 miles here. So you have 150 miles here, 130 degrees here, 100 miles here, and this distance d is the far side. So use the arc cosine. We'll use the cosine law. D is root 150 squared plus 100 squared minus 2 times 150 times 100 times cos 130. And that comes out to 227.6 miles approximately. Now to find theta here, we have three sides, and we have 150 miles, 100 miles, and 227.6 miles. So using the arc cosine law, theta is arc cosine of 150 squared plus 227.6 squared minus 100 squared over 2 times 150 times 227.6. That gets you about 19.7 degrees. And there's your answer. Here we're given two sides. B is 1, C is 3, and alpha is 80 degrees. What's the far side A? What are the two angles, beta and gamma? All right, now side, angle, side, and A is the far side. So we use the cosine law. A is root b squared plus c squared minus 2bc cos alpha. So plug in 1 for B, 3 for C, 1 and 3, and 80 degrees for alpha. So A is the root of 1 squared plus 3 squared minus 2 times 1 times 3 cos 80. And that calculates out to about 2.99301. Pretty close to 3. So this is almost an isosceles triangle. Now having all three sides, B is 1, C is 3, A is 2.99301. We can get beta and gamma by the arc cosine law. Beta is arc cosine of, let's see, 3 squared plus 2.99301 squared minus 1 squared over 2 times 3 times 2.99301. And that gets you about 19.21 degrees. And again, we could find gamma by subtracting alpha and beta from 180, but let's go by original values. Gamma, here's gamma. We take the adjacent sides. B is 1, A is 2.99301, 1 squared plus 2.99301 squared minus far side squared is 3 squared, all over 2 times 1 times 2.99301. And after some calculation, that's about 80.79 degrees. So for this one, we had a side angle side problem. Find the third side, and from the three sides, use the arc cosine law. So that concludes these. Before we go on, next time we'll discuss the area of a triangle. There's a half base times height formula. There are these related to the side angle side problem. Then there's Heron's formula, which gives from three sides gives the area. It's this complicated formula with this complicated derivation, which I will go over next time. It involves a half angle formula and a number of others. And then some examples. After that, we'll have a section on simple and damped harmonic motion. Pretty short section because you could either go into this topic either briefly or at great length, and I go into it briefly. Okay then. That should suffice for today at this moment. All right then. We have done, whoops. Okay, we have concluded our work for today. I open the floor to questions, comments, requests, and suggestions.
Quick question, Professor.
I'm having trouble hearing you.
When is the upcoming?
When is what? Homework? Well, homework 4 will be in well, after we finish the next 2 sections. So it'll be at least a couple of weeks from now. Let's see. Is there a quiz coming up? Good question. Let me double check. Quiz 2 covers 3 and 4. So that'll be also will be after we finish the chapter. Okay. I hope you could hear. Okay, yeah. So next quiz and next homework will both finish through 4. And so we have a couple more sections of 4, area and harmonic. That'll be at least a week. So by next Tuesday, we'll be finished with 4. So I think the Tuesday after that is when the homework is done. Okay. All right. More. Very well then. Motion to adjourn. Is it seconded? I think it is. It is seconded. Okay, great. I shall see you later then. See you on Thursday.
Thank you, Professor.
And a good morning to you all.
Thank you,
Good morning.
Professor.
No problems.
So I had a question.
Yes.
I remember when I reached out to you like in the beginning of the semester and I was having a hard time with the homework.
Yes.
So I haven't completed chapter 1 yet, but I've been meeting with tutors.
Hand it in when you're ready.
Yeah, so is it okay if I want to do it before the midterm grades come out.
Well, I already noted midterm grades, so it is what it is. But don't worry too much. Like
Oh, it's done already?
I already posted them. I don't know when they'll come out.
Oh, okay, because I'm like about halfway done because I wanted to get caught up with the, chapter 2, chapter 3. So chapter 1, I kind of haven't finished yet. But
When you finished and you feel ready, hand it in. I don't take time. Within reason, I don't take points off for late. Okay.
okay.
Sure.
All right. Well, I'll probably send it in probably tomorrow because I ran out of paper.
Okay, fine. Take the time you need and the paper you need.
Okay, sounds good.
All right. And a good morning to you.
All right, toodles.
Toodles.